Hi, everybody. Good evening. I hope you can hear me all right. Okay. So, welcome to the revision session for the course Foundations of Our Software. Um, so, have all of you sort of registered for the exam, or how is it? Have any of you registered for the exam?
Yes.
Okay.
Yes, ma'am.
Okay. All right. Great. So, your exam is on the 3rd of November, right? On Sunday. So, the particularly the admit card and hall ticket and stuff is something that the NPTEL team would be directly handling. But in terms of this course, the main thing is that you would not be really working on R or R Studio during your exam. The questions would be very similar to what you've seen in the assignments in all these weeks. So for now, like you can always like you could copy and paste the codes in R or R Studio and you can see which of the options is correct. But at the same time, over the course of, this, like throughout this course, you would have also gotten an idea um, how to, how you can mentally also solve those commands and think about what sort of an output you're going to get. So that's what is going to help in the exam. You will definitely have the access to an online calculator in case there are some questions which require you to calculate something. But again, those calculations are not going to be very tough. So that's pretty much how the exam thing is going to work. So for today, this revision session, so there's not really anything new that we can talk about. I have just compiled some of the basic or like the more important things that we've covered in the last 12 weeks. So it's like quick crash course, although the disclaimer is that it will not cover everything. So if there are any particular aspects that you want us to discuss today, you can let me know. We can focus more on that. Otherwise, I'll just start sharing my screen and we can just go through, uh, have a quick revision of everything, almost everything. So does that sound good? Or do you have some particular topics that you want to discuss? Yeah. Okay. All right. Anyway, even throughout the session, today's class, if at any point of time you have any question, suggestion, whatever, just either type it in the chat or you can unmute yourselves. Cool. Let me start sharing the screen then. All right. So I don't have any PPT prepared for today. We'll just directly start off with um the course, the revision in the R script. So we've seen so far. So again, what I repeated, like what I mentioned in the first and second week. So whether you use R directly, the R console, or you use it via the R Studio, it doesn't impact how your output is. R Studio makes it a little simpler to navigate through where what is. And so far, we've seen something called the R script, right? So when you go to file, you can press new file and you open R script. So just for today, just one thing that's going to be new for today is I've written the commands in something called R Markdown. So you can give it a go. It's not very different. The organization is, so once you open this, once you click it, it will ask you to give a file name. And it might also ask you to install some things for the first time, but that shouldn't take up a lot of time or space. But anyway, you can give it a try later. The sort of advantage of that is you can see that the code is sort of divided into some chunks. So you can see these gray background. So everything that starts with this sign and that ends with this sign, it's like a chunk. So it's often called the, yeah, some sort of chunk. So since we have had so many things to discuss in the past weeks, if I put everything in a straight line, like just one after the other, it can be a little bit confusing to sort of, just keep a tab of where what is. So it's just a little simpler to organize larger set of codes. Um, So all of them will ultimately, again, it will still be the same way. Whatever commands you execute, they're going to be here in the console. And whatever variables you save, they will still appear in the environment. And if you make some plots, they will still be here in the plots. But it's just the way you're arranging your script, that can be a little bit more convenient. Okay. All right. So generally, whenever you will write a script for yourself, we've talked about that there could be some things called as there could be some commands which are uh, included in the default R, or there could be some commands which will not be there in your base R or the default R, but you'll have to install some packages for it. So the installation happen once, but the loading of libraries happens every time. And it's generally recommended that you load the library at the beginning of your script itself. So very often you might, if you take a look at some commands, some scripts from some people, very often you'll see that mostly libraries are going to be here in the beginning itself. And then you actually start off with your commands. So for today, we don't exactly, we're not going to be using any libraries per se. So I don't have anything in here, but very often you might see some very common libraries like DPL is one very common one. Again, these are just names right now, but if any of you is interested, we can take a look at what these do and explore further. So these two are definitely some of the most commonly used libraries. But again, these are not being discussed in the course, but it's just like an extra information. And of course, the revision session that we are having today, it should not be the only thing that you sort of take a look at before your exam, because it's not possible to cover 12 weeks worth of commands in 1.5 to 2 hours. But let's give it a try. So again, this is more so that it's a quick revision, a recap more so of what was done. So of course, you know that R can be used as a calculator, right? Simple, um, sorry. Yeah, simple mathematical operations of addition, subtraction, multiplication, division, power. So of course, remember these two symbols. They both are they both mean the same thing. So it's both is 2:3, and yeah, both of them are 2:3 here. Okay, just one thing, since I've mentioned this RMD or the R markdown thing. This beginning starting chunk should stay unaffected. Let it be there. It'll already be there in your, when you make the RMD file, just let it be there. And once you're done, like once you have this, you can remove everything that's after it, and you can instead just, you can use Alt Control I. Sorry. Yeah, Alt Control I, and this is going to get sort of added up. So you can see this chunk, everything that you type goes in within these lines, whatever you want to type, right? Okay. This is just random things. Okay. Anyway, this is, again, it's not super important. It's just something new for the class, but not important with respect to the exam. Okay. Coming back. So these are the general operators. And of course, we talked about two more operators. So which is the percent operator, where you can find the, it'll give you the remainder of when you're dividing something by something. And %/% means you'll get the quotient. Okay. So we had this confusion in the class that we were discussing this, that especially when you're working with negative numbers, how do you get what should be the quotient and what should be the remainder? So what we ultimately found out in that is that quotient is always going to be when you divide A by B. So dividend by the divisor, when you divide that, you take the floor. And so again, floor, ceiling, these were largest integer that's less than that, and ceiling is the smallest integer that's greater than that, right? And truncation means you're simply cutting off a certain number, and rounding off is obviously you're rounding off up to that digit. So it's, if it's 5 or greater, you take the larger one. If it's less than 5, you take the smaller one, and so on, right? So the quotient is always going to be the integer less than whatever comes up when you're dividing it normally. And then of course the remainder has to satisfy that condition, right? That your divisor is going to be, your dividend minus divisor into quotient should give you the remainder. So again, this is just to keep in mind if you get some questions which have negative dividend or divisor, then you'll be able to solve this. Uh, Again, let me know if you have any questions, any doubt at any point of time during this class. There's a lot to cover, so and since this is already something we have talked about, most of these commands that you see here, they have already been discussed in the live sessions that I've conducted. So it's not new. So I'll sort of skim through the commands unless any of you point out that there's any question. Okay. All right. And then of course, whether you use the assignment operator or you use the equals to sign, like for example, here it's the is equal to sign, and let's say here there were these assignment operators, these would be the same thing. What you need to ensure is that the arrow of the assignment operator, so there's this less than symbol and a hyphen. So that arrow has to be pointing to the variable that you're assigning the value to, right? You can write it the opposite way, but follow one convention, and this is the convention that's followed. Okay. And let me just remember. Yeah. So you can type in this, of course, manually. So you can type the like the less than symbol and then the hyphen, but there is a there's this shortcut for the assignment operator, which is alt and hyphen. Sorry, yep, alt and hyphen. So alt and hyphen, it gives you this symbol. All right. So, but again, it doesn't really matter if you type it the usual way or using the shortcut, but it's there. So yes, so of course, all of these, so anything that you see in R which has a name followed by these curved brackets, that's a function, that's a built-in function in R, right? So sum, product, square root, so on and so forth. Of course, it's very important to know what the current working directory is, especially when you have to read some files or when you have to save some files, because sometimes it happens that you've just saved a file, saved a plot, but then you can't seem to find it because your working directory was something else. So the advantage with RStudio, of course, is that here, this one, it shows you what your working directory is. But still, if you want to see it as a character input, you can simply type get WD. And if you want to set something, you can write set WD. And of course, here within quotes, you'll have to type whatever the working directory is. And it's going to have these forward slashes. Again, I'm just typing like that, but this is how the syntax is. So get working directory is this, and you can type this back in to change your working directory. And of course, we discussed a lot of search, sort of search, help.search, type of commands in R. You can take a look at I think that was in the first week itself. So those are there. So one of my favorite commands is using the question mark. Okay, so like question mark followed by, let's say sum. Okay. Yeah. Once you do that, um, a help menu here is going to open. It's just going to show you the documentation for that command. And very often, so this is of course useful if you know what the exact command is, but very often it happens that you know the command, but you get confused in terms of what input or inputs does it need, what output or outputs does it give. So in that context, this is going to be helpful. But again, you can directly Google things, of course, and you can also search via R itself. So, of course, these are some more things. So you can see these broom symbols here and there. So if you want to clear your environment or if you want to clear this console, you can use these symbols here. When you want to run this. So what we have been doing so far is selecting one line or multiple lines and then hitting Control Enter. You will also see this run option, whether you use the RMD file or the normal R script, there's going to be a run option. And there is also this in RMD, you can also see this arrow here. So this is also the run arrow. But the thing is that it's going to run the whole thing. So all your commands are going to run within that chunk, within one gray area. It's going to run all of them one after the other. So very often you don't want to run all your lines. Like for example, these are just empty lines, right? They're not going to give me any output. They're going to give me errors, in fact. So I don't want to run all of that. But if you think the entire thing needs to be run, then you don't need to select anything. You just press this button here. So let's just try and let's see what it does. So if I run this thing, so you see very quickly, it did the whole thing. It did these calculations. They were fine. But then here, it gave an error because A not found. Obviously, I've just written variables here so that you can see what it is. You can assign values A and B. You can have different values and then it's going to run. But then it just gave an error and it stopped. Okay. So that's how it's going to be. But if you think that your command in that entire chunk is going to run without error, then just hit that run button. Okay. So that's the basics. And then, of course, we talked about vectors, which is one of the major data types that people use in R. So three of the very common ways of defining vectors is using the combine or the C command. So this is where you explicitly specify what each of the elements is. It can be tedious, but you know what each of them are. You don't have to, there won't be any doubt. And then the other command is seek or sequence, where you type the starting value, then you type the maximum value that it should have. It should not go beyond this. Maximum or minimum. I mean, the last value should not be beyond this. And the third value here is the step size. So basically in this example, it's going to start from 1, then it's going to go 3, and then 5, and then 7, and then 9, and then it stops. And then of course, here, if I would have had 8, then you would have just had 1, 3, 5, 7. You would not have had 9 here. Okay. And then of course, if you are not interested in, if you just want the step size of 1 or -1, then you can have the colon symbol. So 1:9 or 9:1, whatever the order is, whether it's increasing or decreasing, the step size is going to be 1. So these are the three only sort of ways in which you can define vectors in R. And then of course you can do scalar operations and vector operations. So let's take the example of these three vectors, right? So I'll just run them one by one. So you can see here, we have X is a 6, it's a vector of length 6, Y is also a vector of length 6, and Z is a character vector, which is of length 7. So of course, scalar operations are easy. So it's again, you're using our, this thing as a calculator, but one of the inputs, so when you're adding or subtracting anything, when you're using a calculator at any point of time, you just have two inputs. There are just two numbers that you're working with. When you're using scalar plus scalar, that's the usual way in which you use a calculator. But when you're saying scalar and vector, then it means one of the elements is, one of those entries is a vector and the other is a scalar. So what happens is you sort of are repeating that step, that calculation, those many times. So x plus 3 means you're adding 3 to each of the elements of your vector x. X to the power 2, likewise, you're squaring up each of your elements of vector x. So that's easy. So these are the scalar operations. Okay, not very difficult. When you're doing vector operations, when you're doing vector plus vector, it only makes sense if you have the same number ideally you should have the same number of elements in both your vectors. So it's a 1:1 sort of thing. So the first element gets added to the first element, second to the second element, and so on up until sixth element to the sixth element, right? So when I do that, when I just do x plus y, it does not give any error, it does not give any warning, and it does the calculations appropriately. Now let's define two more vectors. So again, numeric vectors a and b. One of them has length 3, one of them has length 4. Now, what we've seen this earlier as well. So if you have two vectors which are in different lengths, but the length of the longer vector is a multiple of the length of the shorter vector. If that happens, then it does not give any warning. Okay, it does not give any error. So because what it's able to do is it's able to repeat the entire vector completely. So it does this vector once, and then it says it repeats the vector another time. So 3 and 3, that gives you 6. So it's repeated entirely. But when you come to the vector b, when you're doing x plus b, then what happens? It gives you this output. So it does 10 plus 10, and then it does 20 plus 20 and 30 plus 30. And then it does, sorry, yeah, with x, right? Okay. So 10 plus 1, 20 plus 2, 30 plus 3, and then it does 40 plus 4. But then it goes back and does 10 plus 5, 20 plus 6, and then it stops. So it will repeat only one of the vectors throughout the thing, but it did not repeat the shorter vector entirely. It repeated just two of the four elements, right? Because the longer object length is not a multiple of the shorter object length. So while it is able to calculate it, it gives a warning. But even this was something that was not entirely correct in some way, but it does not give you a warning. So you should be very, very careful when you're doing such calculations because it's easy to miss this out. All right. Then of course, we talked about this thing as well. So these two functions, mean and sum. So we often think of them as very similar functions, right? Because when you want to find the mean or the average of a set of numbers, you first add them up and then you divide them by the number of elements you had, right? Number of numbers you had. So there are two ways in which, so let's say I want to find the sum of numbers from 1 to 6. So I can either write them as individual numbers, and so now what is line number 106 telling you? That I've given 6 inputs to the function sum. Each of these are directly an input to the function. So I'm giving it 6 inputs. And in line number 105, what I'm doing is I'm giving it a single input, but that input is not individual numbers. That input is now a vector of 6 numbers, right? So this is what these two things are. Overall, they look similar, but internally, the way R perceives it is different. However, when you run both of these lines, you get the same output. You get the same and the correct output in both cases. So it's okay. So you don't it doesn't seem as if you need to be very careful about this. But when you come to the function mean, then when you do the same thing, then you get 3.5 when you fed it as a vector, which is correct. But when you gave it 6 individual inputs, it gave the first input as the output, and it did not give any warning, and it also did not give any error, right? Had it given a warning or an error, it would have been nicer because we know the answer is incorrect. But the rationale behind this output is that mean can accept only one input, right? So it accepted the first thing as the input and it simply ignored everything else. Here, this entire thing, the entire vector is just one input. So it's fine. Here, it considered this first element as the input only. So it just said you want to find the mean of 1. Okay, the mean of 1 is 1. End of the story. So some operators, some functions may behave fine, irrespective of how you feed the values. But for some of them, it's very important that the format is correct. So the best way out is to use C, to specify multiple numbers as a vector wherever possible. Okay. All right, are we good until here? All clear? Does it make sense? Yeah. All right, good. Okay, thanks. Right. So then, of course, there's the seek or the sequence function. So the main three, so mostly we need to specify three arguments. Generally, it's from, to, and by. So this is what we had seen here also. When we are not specifying anything, the order is from, to, by. Because these are positional arguments, right? If you've not specified the names, then the position becomes important. But if you have specified the names, then the position is not important. The names are important. So again, this is also the same thing. But here we have just switched up their positions. We don't have from to by, we have by to from. But since each of these are named, it doesn't matter. So of course, here we are saying go from 3 to 7 in sizes of 0.3. So that's fine. But now here we are saying that you go from 3 to 7 in the sizes of minus 0.3. So obviously you can't go from 3 to 7 in minus intervals. So the first one runs fine, but the second one gives you an error. The third one is also going to give you the same output as the first one because we just switched places of these named arguments. But since they are named, R has no problem dealing with it. And then in the other example, we either specify a to or a from number. We specify the step size and we specify how many elements we want. So ultimately, it's still the same thing. You want it to be able to stop somewhere, whether you stop it by giving it the lower and upper limits, or whether you stop it by specifying how many you want and one of these two limits. So we are saying go up till 7 in steps of 0.3 and just have 5 elements. So you can sort of backtrace that if 7 is where you want to go, then there'll be 4 numbers before it in steps of minus 0.3. So it's sort of back calculation. And it works the other way when you have starting with from. So you start from 4, you go in steps of 0.9, and you have 4 such elements. So 4, 4.9, 5.8, 6.7. Okay. And then we talked about the repeat function. So within the repeat function, the first element has to be what you want to repeat. It could be a single value, it could be a vector, it could be both character vector, numeric vector. So it's easier to, I just have one example here, but of course you can give it a try with single element also. So there are two things. Suppose if we have apple and bananas here, then there are two ways in which the repetition can happen. Either you repeat it apple banana and then again apple banana and then again apple banana, or you want to repeat first apple multiple times and then banana multiple times. Okay. So there are two arguments within the rep function that you need to be either, like you'll use either one of them or both of them. So when you say each, then that's how many times each of them is going to be repeated in that order. So it's going to be apple, 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 banana, banana, banana. And then if you say times, then it's going to be apple, banana, apple, banana. So it's going to consider the whole vector as one thing and then just have it one more time. And then in this example, since we have both of them, so it's just internally the way R does it is it first repeats each of them and then times that whole thing. So if I run this, you can see it's each. So apple, 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 banana, banana, banana. That's the first time. And then we said do it twice. Then this is the second time. Okay. So that's how the rep function works. Okay, I think I have, yeah. So when you're doing the sorting, so let's say we have this X here, it's already sorted. Let's take another example here then. Okay, let's say I just have a random. Okay, let's say this is the thing. I just copy pasted these blindly, so I don't have an example, correct example. Okay, let's call it, yeah, let's just call this X anyway. So this is your X vector. If you want to sort it, so the increasing order, if you want to sort it in the increasing order, if I hit this, then it's just going to arrange your elements in increasing order. If you want them in decreasing or descending order, then you have to specify decreasing is true. So it does that, right? So you can think that decreasing false is your default, right? So default is when you don't always need to specify some arguments, are just internally sort of sets it to some one of the possible values. And very often when you are reading about the function here, it will specify what the default is. So if I sort of do sort here, so you can see here, this is what the function is. So X is your, generally it's a vector, right? And decreasing false is the default. So you can specify decreasing true, and then it does the opposite thing. Okay. Now, on the other hand, what the order function does is it's going to give you the position of the elements in which they are to be sorted. So for example, when we did the increasing or ascending order thing, 0 had to come first, and then 1, and then 2, and then 4, and then 9. So the indices of these were 5, and then 1, and 3, and 2, and 4. So that is what it gave you. It gave you the indices of your vectors that should be used to arrange your vector in an increasing or a decreasing order. So it gives you the opposite here. So yeah, so I did not explicitly specify this here. I don't think I have to afterwards. Yeah, so if you want to access vector elements, so definitely what you are going to do is the square bracket, and within the square bracket, if you want to access one element, so you just specify that position. You can make a smaller vector. So this is, it's sort of like vector within a vector thing. But if you want to specify a vector, then any of these formats can go within this square bracket. So for example, if I want to set, I want all these single elements here, the single alphabet things. So I want 1, and then I want 3, and then I want 5 and 7. Yeah. So if I want this, then I got this. The output is a vector. This thing is a vector. This thing in itself is a vector, right? So a vector with a vector gives a vector. So that's a lot of things. But yeah, I think by now this would have become a little more clearer. You can sort of appreciate and understand what this means. But if not, a little more practice should do the task. Okay. Should do the trick. Okay, anyway. So that's about vectors. And then we jump into two-dimensional objects, two-dimensional variables, which is matrices. Again, there are going to be 4 arguments that are important. One is what data you want to be there in R, in the matrix. Again, it's good if you can have as many elements given as vector as there are going to be in the matrix. So let's say you have a matrix which has 3 rows and 2 columns. Okay, so we call it like a 3 by 2 matrix. Number of rows always is always set before number of columns. So if you have 6 elements, then it's good that you specify a vector which also has 6 elements, because again, if you specify a vector which has lesser or more elements than needed, then it'll work the same way. It'll either repeat some of the elements or it'll skip some of the elements. But again, it may not always give you a warning, so you may not be aware of that something incorrect is happening or something that you have probably not desired is happening. So it's good to be mindful of that. So here, the first argument generally is going to be a vector of some elements. Again, you can have numbers, you can have characters. Then of course you have to specify how many rows and how many columns you want in the matrix. And then you want to specify in what order to fill them. Should you fill it by column? So the first column gets filled, then the second column, and then the third column, and so on. Or you want it to be filled by row. So the first row, then the second row, then the third row, and so on. Okay. Now, I it's quite difficult to remember what the default is in different functions. So, like for example, for matrix by row, false is the default. But if you don't remember, if you don't want to rely on that, then I will advise that you always specify what the by row you want to be, right? So here, when I'm specifying by row false, I am saying it again, right? It R would have done that anyway, but I'm just explicitly mentioning it so that now I know that, okay, there's no chance for an error. There's no chance that I might have thought it differently. So it's just going to make your command more robust so that you don't mistakenly do the other way around. But of course, if you remember, then you don't need to specify this thing here, right? Okay. So like, yeah, for example, in this, for the matrix O, I did not specify the by row argument. So it will directly consider it to be filled by columns, right? By row is false. That means it's going to fill column wise. Let's just run some of these matrices here, M and O, P, Q. So again, what you can see in all of them, all of these are going to give you the exact same matrix. Not same, but yeah, you can see that the arrangement is the same, the order is the same. So they're all 3 by 2 matrices because we have specified 3 row 2 column, 3 row 2 column, 3 row 2 column. In this one, I have not mentioned any names of the arguments, so I'm relying on the positions. Again, this is not a good idea if you have any doubt, but if you're very, very sure of what the sorry, 1 second. Yeah. So if you're very, very sure of the order in which these arguments appear, then it's okay. You can skip the names. But if you're sure of the names, then it doesn't matter that you follow the order or not. Then positions are not important. You just have to have the right name and you can put them in whichever order is convenient for you. Okay. So that's about it. So this is what your matrix is looking like. So here we filled it by row. And for matrix N, here we filled it by column. All right. And then again, you want to fill in, you want to access elements of a matrix, whether it's one element or multiple elements. You always specify which row you want first, and then you specify which column. So it's again square bracket. There's going to be a number or more numbers before the comma, and there's going to be one or more numbers after the comma. Again, here also just like, so before the comma, if you have to have more than one number, it needs to be in the form of a vector, right? Because you can't have multiple commas, right? So for example, if I want to access first and second column and third row, okay? So if I just write first and second column, oh, sorry, third row, and then if I write first and second column, which comma do I take to be separating my rows and columns, right? So these have to be in a bracket. But then just taking a bracket here doesn't make sense. Uh, R is not able to understand what this bracket is doing. It's right. R expected a number here. So the C does the task. Okay. So I got the third row and first and second column, both elements. All right. So again, these things are, so you're accessing one of the elements here. Of course, if you're accessing an element which is not present in the matrix, it's going to give you an error, and that error is going to be subscript out of bounds. This is very often, this error comes very, very often when you're working with a lot of data. So you can't keep opening it here. Like here, you can see, okay, there is no third column. So it's easy to remember. But when you're working with a larger data and when you have like lots of commands, so within a command, you're making some table or some matrix, and then you're using that matrix. This is a very common error. Okay. So yeah, so in all of these, so if you don't specify anything, then it means you're taking the entire set. So I'm saying here third third row and all the columns here, right? So it's giving me the same thing as this last line. All right. And then, of course, for a matrix, you can check its dimensions. That's also a vector. It's a two element. Yeah, it's a two element vector. You can see number of rows, number of columns. When you say length, it just gives you how many elements there are, because length function is generally used in terms of vectors when you want to specify, when you want to find out the length of the vector. But when you're working with the matrices, length means how many elements there are. Okay. Now, uh, these are all numeric matrices. You can obviously have character matrix, so where all the elements are characters. But the disadvantage with matrices is you cannot have both sorts of data. If you're specifying a matrix with something like this, so this is the shortcoming of both vectors and matrices, that you can't have two types of data in it. So in this case, uh, the vector itself gets changed into new all same type, and then the matrix also does that. So if you're going to check the mode which gives you data type, the matrix M that we saw earlier, they were numeric. Matrix R here is completely character, but matrix S here also shows character, because ultimately, if you see this, you'll see double quotes around all your elements. It doesn't matter whether they are in one column or in different columns. Okay. Then, of course, your matrices that as we can see here, there can be row names and character name, row names and call names. These are not absolutely essential for matrices, so they're more important when you are talking about data frames, and we'll see that, like we just saw them that a couple of weeks ago. But anyway, that's where this is more important, but let's just anyway talk about it. So row indices and column indices are always going to be there. The first column can always be accessed by this sort of a notation, right? And this is for the second column. Likewise, this is for the first row, second row, third row. So these are always going to be there whether you see it or not. But in addition to these indices, you can also have names. So you can check the row names and you can check the call names using the call names function. So call names, and then within brackets, you write the name of the matrix or the data frame. And if you want to set it, then you can have a vector and point it towards call names of that data frame or call names of that matrix. Again, it would not be possible to discuss everything in detail. So let me know if anything has to be expanded upon. Otherwise, we'll go at this pace throughout. Okay. Then, of course, in matrices, you can have something like diagonal matrices, wherein you're only filling the diagonal elements. And what are diagonal elements? Where the row index and the column index is the same. Now, these don't necessarily have to be square matrices, right? So, for example, if I specify, let's say the second example, E, for example, in here. So it has 3 columns and 5 rows, right? So these elements, 1, 1, 2, 2, 3, 3, these were the elements that are diagonal elements. So it just filled these there. If you specify a vector which is smaller than the number of diagonal elements, then you can see here that what it did was it repeated. So the first element was 1, second was 2, but for the third element, it again started repeating that vector that you gave as data. But this time, even though the smaller vector and the longer vector, these were not multiples, it did not give any error, right? So if this is the way you intended it to be, great. Otherwise, R did not give you any warning this time. Okay. All right. Then let's just have some more examples here. And then, yeah, of course, if you specify just one value, then all your diagonal elements are going to be that value. So that should be okay. Now, in addition to just making a matrix, there are also, when you're talking about numeric matrix, there are a lot of mathematical operations you can do here. But the more important thing that you want to remember is when you do matrix multiplication, um, then the format sort of has to be of the form, let's say A, if you have a matrix A, B, then the other one should be B and C. Okay. So it means A rows, B columns, and B rows, C columns. So if this is the sort of arrangement, if the number of columns in the first matrix, whatever you're writing first, and number of rows in the second matrix, if that number is the same, then you can do matrix multiplication, and that you do by this operation, percent asterisk percent. So for M1 and M2, you can see here. Okay, I did not run these. All right. So you can see here, M1 is 3:2, like 3 cross 2, and M2 is 2 cross 2. So it does satisfy this thing, right? Right. So this 2 and this 2, that's the same. So you are able to run this and it gives you an output. And of course, the output is going to be of the form A cross C. So you got a 3x2 matrix. But if you do this thing, M1 into M3, which is 3 into 2, and you multiply that by 3 by 3, then it doesn't give you any output. So it just says non-conformable arguments, gives an error, and it stops. Instead, again, you can just like we did vector with vector addition, it's basically you're overlaying two vectors, right? In terms of matrix also, you can do that. You're sort of one matrix, and entirely element wise, you are subtracting or adding or multiplying matrix, that you can do. Of course, in that case, they have to be the exact same dimension. If it's 3 by 2, the other one should also be 3 by 2. So for example, M1 and M4 here. Yeah, M1 and M4 here, they are the same same dimensions. So you can simply add up them element wise. 1 gets added to 4, 2 gets added to 2, and so on. All right. And then of course, the other things you can do is binding matrices, whether you bind them one below the other or you bind them left to right. So again, if you're binding them one below the other, you need to ensure that both of them have the same number of columns. And if you're binding them left to right, then you need to ensure they have the same number of rows. Can you tell me which is called R bind and which is called C bind? Do we remember? When you have two matrices, one below the other, what is going to be called? Are you binding columns or are you binding rows?
The R1.
Yes, correct. So you can see here with M1 and M2, since you have the same number of columns, you can place them one below the other. So you're binding rows. So rows and rows, like rows below rows. But M1 and M3 can't work because number of columns of the matrices must match. That did not match. And the opposite is true for C bind. So for C bind, M1 and M2 is not going to work because one had 3 rows and the other had 2 rows. Yep. But C bind on M1 and M3 is going to work because the number of rows are the same. Okay. So this is important. Each row has each column and each column has each row. All right. Again, these topics are not exactly in the same order as they would have been across weeks, but it's mostly like that. Then logical operations was also discussed. So of course, whatever you're starting off with, very often these are user input. These numbers are input by users, and you want to check if it's greater than 40, if it's less than 40, if it's greater than equal to something, less than equal to something, if it's exactly equal to something, if it's not equal to something. So these are the 6 operators that you can check when you have one condition that you want to test. So R generally gives the output as true or false, like capital TRUE and capital FALSE. When true and false can be an input somewhere, when you have to type it true and false, you can also type capital T and capital F. That will also do the trick. But this is why it's recommended that when you're specifying these elements, sorry, when you're specifying these vectors, it's better to not use capital T and capital F as vector names, right? So we've had a lot of capital that we are using here now. So it's just better that you don't use F or T for that, because R can get confused and then your commands may not work the way you want. So it's just better to avoid it if you're unsure of how it's going to work. And if you're working with multiple conditions, so we generally talk about two conditions. So if both of them are true, then it's okay. If both of them are false, then also it's okay. But if one is true and one is false, if you want both of them to be true, so if you want like an AND operation on them, so true and false gives you false, because AND sort of means that it has to be perfect. So AND is true only in this case when both of them are true. Or is like, I just want one of them to be true. So in each of these three cases, you can see or is true. It's just when both of them are false, then it's just false. So this is the example. So suppose I've specified x is 20. Then x is less than 15 and x is greater than 5. So x is less than 15 is false, but x greater than 5 is true. So false and true, right? And in the other case, it's false or true. So if I run this line, sorry. If I run this line, what happened? Oh, wait, I did not specify x. So x is 20, for example, here. Now, if I run these two lines, so you can see here, when you're saying and, it gives you false. When you say or, then it gives you true. This is like this, I don't know, it's called the truth table, right? Okay. Of course, you can work on these when you have vectors. So, for example, you just saw here. So I had specified x earlier as something that we just saw up just a few lines back, right? So it's going to do all the things on all the elements, and it's going to give you a final output also element wise. No elements are going to be combined here. Okay. Here, uh, I'll just recommend you to not use the double and the double or. It generally stops at the first element, but I've not been able to figure out how exactly it's working. It's been a while, but yeah, mostly what you have to be careful with is, I mean, if you just use the simple single and single or, that should do the work. So your and is this ampersand symbol that's above the number 7 on the keyboard, and this or is this pipe symbol that's just below the enter key. Sorry, just below the backspace key, like between the backspace and enter keys on the keyboard. So you have to type shift and press the buttons. Okay. Fine. Then of course you can use these conditions also to access elements of vectors or matrices, right? So for example, let's say we have this vector. Yeah, let's say we have this vector y. So we have this. So if I want to access just some elements, so I can write y, where y is greater than, so suppose I want to find y greater than -20. Okay, if I run that, then it just says it just gives me a, okay, let's just do it -40 for now. Okay, so it just gives me a vector of trues and false element wise. Okay, now there are two ways of doing it. So if I write which y greater than -40, then what it's going to do is it's just going to give me the indices where it was true, right? So when I did greater than 40, it just gave me a vector of trues and false. And then when I specify which, it's giving me only the indices of where it's true. But you see, both of these are sort of the same information, right? It is the same information. So what I can do is I can write either of these things within my square bracket. Whether I write this or whether I write this within the square bracket. Let me just make it a little clearer. Right? Yeah. Okay. So again, if I run both of these lines, it gives me the same answer because ultimately it's giving me, I'm able to get the element at positions 5 and 6 in both cases. Okay. Whether it's because of this vector or whether it's because I'm just taking the 5th and 6th element, it does the same work. Okay. So whether you're using the which function or you're directly using condition. I mean, you're using condition both ways, but whether using which or not, it normally does not matter. But there could always be some cases where using one versus the other can give you some differences. Okay, then of course, more reserved words and things we saw were NA and null and not a number of things. NA and null are they're more important because you can specify those explicitly in your they're very common, they'll be present in your data. Very often there could be some missing data. So how you want to deal with it depends case to case. But sometimes you may want to replace it with a 0. Sometimes you may want to remove that row or sometimes remove that column entirely. It depends. Okay. All right. So far, so good. Any questions? Okay. All right. Yeah. So after this, we come to conditional statements, which are the if-else statements. Again, there was one more sort of an if-else we discussed, but I've not had a chance to it. I don't think I've put it up here. But okay. So again, the if-else statement, the most important thing to remember about the if-else statement is it will accept only one input at a time. So you can only do if-else on a single variable, on a single number, or a single character. No vectors this time. Okay. So yeah. So if you have, so if the condition within if, so you write if, then you write curved bracket, you write your condition, and then it's advisable to put these curly brackets. If you just have one line after if, you don't necessarily need to put the curly brackets, but it's always advisable. Okay. So again, you put these curly brackets and within that becomes a chunk. Within that, you can write whatever lines you want to be executed only if the condition is true. So if you just have this much, if you don't have any else sort of a statement, then if the condition is false, nothing happens. That's it. But if you want something to happen when it's true and something else to happen when it's false, then you have to specify the else command here. Okay. So for example, if I say A is 4, and if I run this chunk, then it's just going to print yes, because A is indeed less than 5. But if my value of A was instead 9, and then if I ran the whole thing, then it would have printed no. Okay. Then of course you can have nested if else. So you can have if else within if else. Again, what it's going to be doing is so you go within if or else, and then within that you're executing the lines, and then if you encounter another if else, you do the same thing iteratively. Another thing sort of what you may want to, what we just talked about combining these things is you can specify it like this. If A is greater than 10 and B is less than 6, then what you can do? Then you can do print, let's say case 1, and then maybe you want to do else if, so you can have 4 cases and all, right? X is greater than 10 and B is greater than equal to 6. Then you can print that it's, sorry, this might take a while, but I hope it makes sense. Then you print case 2. Then you say else if, what are the other conditions we have? That A is less than equal to 10, and B is, let's say, greater than. Okay, actually, you could just convert this one. So let's say A is less than 4 and B is less than 6. Let's call it case 2. Let's call this. Then A is greater than equal to 4. And B is greater than equal to 6. This becomes case 3. Sorry. Print case 3. And then there's just one case possible, right? So you just specify else and just say print case 4. Now you can give it a go. So both of these loops. So one of them is a nested if else. The other one sort of like a consecutive if else. So if else, if else, if else. So both of them should give you the exact same output irrespective of whatever if else values are. I mean, these are just two different ways of writing the same thing. It should be working fine. I can double check, but yeah, give it a go. Right. So again, there are two ways of doing the exact same thing. There's no correct, more appropriate way. Both of them are fine. So yeah, that's okay. All right. Then we come to using loops. So again, when you want to do sort of the exact same thing for all your elements of the vector, then you use loops. Two of the majorly used loops are for and while. For loop is slightly more preferred sometimes because uh, there's sort of never a possibility of running into an infinite loop. So you already specify what your counter is going to be, right? So you already start off with a vector that's going to serve as your counter. So your I, which is the counter variable, these are not actual names, but so suppose this variable is what's going to iteratively change its value. It'll either go through all the elements of vector 1 or it'll go to all the elements of vector 2, right? And then you just do something, you print whatever, but you don't need to sort of update that counter. Whereas in case of the while loop, you are specifying an initial value, you are specifying a final value, and you're specifying how to increase it every time, how to change it every time. Okay. So while loop, I think as far as I know, it mostly just works with characters. Sorry, it mostly just works with numbers. I'm not sure how one would work with characters when using a while loop. But in terms of a for loop, character, number, both of them are fine. So personal preference for me is it's a for loop, but again, both of them are fine. Okay. And then very often it's nice to make a function when you're doing a lot of steps together repeatedly, but you don't you're not necessarily repeating it one after the other as you do in a loop. But let's say, so for example, the sum function, right? Or the sqrt function. You will use it, let's say, almost every day, but you're not doing all of those together. You're not specifying, okay, I want to find the square root of 2 and 3 and 5 and 9 and 10. You're not specifying all of them all together. But it's nice to not write how to find a square root, right? You know how to find that square root. There's this long calculation that we did in school. You're not doing all of that. You're just simply specifying sqrt and you're giving that input. Likewise, instead of finding sqrt, let's say you wanted, it's a complicated thing. It's a, let's say every day or whenever you're doing this, you want to find the square of something, you want to add something and then find the square root. If this is something you have to do every day, then you just specify, you don't write this long thing every day. Instead, you just assign it as a function. You're calling it myfunc. And then you say that, okay, this function accepts one input by the user, and then it returns a value after doing this calculation. So when you do that, imagine this is SQRT. So what you're saying is SQRT 40. But instead, what you're doing is you're squaring it up, adding 10, and then finding the square root. So it's going to be slightly different than the input. Yeah, you just need to run this once, and then when you run this, okay, that's what you get. Okay, you can save this as A, you can save this as X, whatever, right? But if you have to find the square root, you have to find the same thing every day. If you don't give it any input, then it just gives you one fixed answer every time. It will always give you 30.1662. Okay. And then of course you can specify multiple inputs. I've not written that here. So my func 3. Let's say I'm giving it input 7, 1, and 3. If I run that, it gives me 4, because what it's doing is it's multiplying the first two values and then it's subtracting the third one. So 7 into 1 minus 3. That gives you 4. Yeah, so one thing about the RMD or the R Markdown file is the output of every chunk, it comes up here in the console, of course, but it also comes up just below the chunk itself. So it can help. So I will not be discussing a lot about the functionality of the RMD file, but you can run the entire script and you can sort of export it like a PDF. So you can have the whole thing that, okay, these are my codes, these are the outputs every time. Okay, fine. Next up, we talked about lists. So the major advantage of lists is that you can have different types of data saved, not just numeric and character, but also numeric numbers, just numbers, just simple characters, or they can be vectors, they can be matrices, they can be data frames. Uh, Sky is the limit. But the important sort of thing is that there's two slightly different ways in which you can access them. It can be a little bit confusing, but it'll come to you with practice. So of course, so what I've done here is these are the exact same lists, but in one case, I've given each of the elements a name, E1, E2, E3, E4, E5, and the other one I've not. So if I just type in L1 and L2 here, so what you can see here is, of course, you can access these by their positions. So the first element, the second element, and so on. But in the other case, in addition to those element positions, so remember, I mentioned this when we talked about row names and call names. Indices will always be there. A first element is always a first element. Even if you call it E20, even if you give it a name E20, doesn't matter. It's still the first element, right? So of course, you can access these elements by their positions, but now you can also access them by their names. So there is an additional way in which you can access those. So just to double check what we are doing. Um, yeah, okay. So if I want the third element, which is this number 2 here, if I write L13, then I get the third element, but I don't get that third element as a single number. I get that as element of a vector. Okay, this position thing, this sort of numbering system here indicates that it's a position of, it's one of the elements of the list, right? But likewise, if I write L23 and within the square bracket, if I write the name, then I get the same thing. Okay. Normally, I should have just gotten this thing, just this thing, right? This is how I get all these outputs, right? It's a single output, single element, single number. So that's what I should have gotten. If I want that, I need to specify it with a double square bracket. If I do that, and instead of using double square bracket, I can also specify using the dollar symbol. So, these three ways give me the element as a list element, and these three here give me the element as its actual form. Okay, so this is not, I can understand this is not very intuitive in the first go, but the more you use it, the more clear it's going to become. Okay, and then if you want to specify, if you want to add another um, element to a vector, element to a list, you can say append. So append to L1, you append the number 10. And if you're not saving it anywhere, then it's just going to display. It's not going to overwrite L1. So you see L1 here is a list of 5. Even if I run this, L1 still says a list of 5, but here is just printed. But if rather here I write, if I overwrite this, now if I run this, I won't get an output, but this has gotten updated. Okay. And then of course you can also append something after some position. So if you say after 1, then the first element stays the same. This becomes your second element, and all the actual second element becomes third becomes fourth, so on. Okay. All right. Then we talked about data frames. So the good aspect about data frames is that each of the columns can be a different type of data. Okay, so think about the best way to remember this is, suppose you have like a school attendance sheet, or like information about students enrolled in a class. So you'll have name, there's going to be character, you're going to have, let's say, roll numbers. Now they could be characters or they could be numbers. Then there'll be date of births, that'll be date format. Okay, I don't have that date format sort of recap in here, but we also talked about how to handle dates in R, right? And then something, you can have addresses, which will again be numbers, again be characters. And then maybe very often schools have like a house system. So you can have that as factors, right? Which of the 4 houses are the students belonging to? So that sort of a data is what a data frame can handle. So typically this is how you define a data frame. So you say data.frame, and then column wise, you'll specify each column. So call name. So this is call 1 is the name of my first column. I could have had it as name, as whatever name you want. So this call 1, call 2, call 3 is what is finally going to be the call names or the column names of your data frame. So here I'm making a data frame which is 4 elements. So each column should have 4 elements, right? 4 rows. Yeah, data frame with 4 rows. So each column should have 4 elements to it. So this has 4 character elements. This has 4 number elements of 5, 5, 5, 5. And this has 4 factors. Now, we also did not explicitly talk about factors, but when you're specifying something as a factor, if you specify what order of levels you want, that's great. If not, for numbers, it's going to be in the increasing order, and for characters, it's going to be in the alphabetical order. Okay, so that's how it's going to look like. So I have this data frame here. If we take a look at, so if we take a look at what it looks like, so this is what it is. So that's fine. You can take a look at the structure. So that's how it is. So you have character, you have number, and then you have a factor with 4 levels. So again, you see it's 3, 2, 4, 1 because what happened here? 3, 2, 4, 1. Why did it do 3, 2, 4, 1? Oh, wait, okay, sorry. Yeah, so it's going to arrange this alphabetically. So it's going to say rain, and then spring, then summer, and then winter. And the way, in the order in which it appeared was summer was first. So it was 3. Then spring appeared, so it was 2. Then winter appeared, so that was 4. And then rain appeared, but it was 1. So 3, 2, 4, 1 is the order in which your factors appeared. This one here, I have the first column, I have the second column. For the third column, I did not specify a name, a column name. And instead of the fourth column, I instead gave it a 2-column matrix. So effectively, it became a 5-column data frame. First, second, third, fourth, fifth. And now you can see it just gave it random. These are not very random, but these are not great column names. So this is how you change or assign column names. First is you want to check what the column names are. So you write col names of df2. You check that, that's fine. Then you want to assign it. So again, just have a vector and assign it to this. So do that. And if you want to just change one of them. So right now the call names are these. If let's say you just want the third one to be changed to call 2, okay? Then just say call 2, or sorry, call 3 is the third element. If you specify that, and if you run this, then just the third element got changed. This one here, it's not going to work. Because you see this matrix right here has 3 rows. So it's just going to give you an error. Different rows are a problem. Here you see this one was not a problem. You repeated 5 just 2 times because again, 4 is a multiple of 2. It did not give any error. It did not give any warning. But when it does, when I specify it here, it shows that, okay, 4, 3, 2, you're giving it different rows. Okay. Yeah, there's just a few more things remaining. I don't think I have the commands for that written here, but let me know if you want to discuss this. But the other thing is, of course, you want to subset data frames, right? So, for example, you can write subset df1. So this was df1, right? Now, if I just want, so if I just want, let's say where my, yeah, okay. Yeah, df1, and then you can have your condition that let's say, okay, call 2 has to be greater than 4. If I say that, then it gives me everything because all the elements are greater than 4. But if I say all the elements are greater than 6, okay, so by the way, if you see the output's not coming because the output's coming here, okay, just below the chunk. If I run this one, it just says 0 rows because there is no output where call 2 is greater than 6. Okay, but fine, that's how you do a subsetting. Then you can read Excel type files. I've said Excel type files because they are, I should say, tabular data. That's a better term. So you can use the read.csv or read.table function. For read.csv, just specifying the file name should be enough. Of course, you can specify whether you have headers or not. That will be nice. But for read.table, one additional argument that you need to tell is what the separator is. Whether the separator is a tab, or it's a space, or a semicolon, or a comma. So you can use the read.table command. Okay. There is a read_excel command as well, which you can get through the XLSX function. Oh, sorry, SLXX command package. But I'll just advise you that if you have, for your actual work, if you have Excel files, it's better to convert them into a CSV and then read that into R rather than reading the Excel file. Okay. We also talked about some other functions. So there's a paste and a paste 0 function where you want to just combine two. These are all for characters. String split, again, you can split a single value into multiple elements if there's a separating string in between them. So here you specify the separator. Here also you specify a separator for paste. For paste 0, the separator is nothing. Sub is when you want to substitute at just one position. And G sub is when you want to substitute globally. So you specify where to substitute, what to find, and what to substitute it with. And then grep is just when you want to find something. Find something in what? That's the thing. Again, it'll just take too long to discuss each of them individually. We've already taken a look at all of that. So I'm sure you'll be able to find that. And then in the last session, which was about 10 days ago, we talked about making some plots. So there are broadly these 4 plots that we discovered: scatter plot or the XY plot, the histogram where you have continuous data on the x-axis and you sort of divide your data into intervals and see what the frequency is for each interval. And then there's bar plot where you generally have categorical data. You can also have your continuous data as a bar plot, but generally a bar plot is for categorical data. So you can sort of plot how many, what is for each category. So how many times did it rain in, let's say, May, how many times did it rain in June, so on. And pie chart is, of course, out of 100%, what percentage do each of your categories have, something like that. Okay. So that's sort of like a crash revision recap of whatever we saw in the last 12 weeks for this course. It's been a good experience for me so far, learning all of this. I hope it's similar for you. Do we have any questions? No questions, anybody? Okay. If not, then thank you for joining this one. And for those of you who are going to be appearing in the exam, all the best. Up until exams, if you still have any questions, there's always the discussion forum that you can post your questions to. There will also be a revision session happening tomorrow. The Tuesdays live sessions, the other T is going to be taking that session tomorrow. So, sorry, if you still have any questions, you can ask there. All right. Thank you so much, everybody, for joining in. I'll stop share and maybe I'll see you again next semester in some other course. All right. Good luck, everybody. Thank you so much. Bye-bye. Good night.